I got a smile. It's hopefully there, you guys.
Okay, so since we're running about 10 minutes behind, let's get started right away. EC28, whenever you're ready, please go.
Hello, we're EC28. We're doing a zero emissions bicycle. My name is Jared Zanoda. This is Seth Simpson, and that's Tyler Petras. To recap on our previous two business with you guys, we are building an electric bicycle which is supposed to be flexible with pedal assist that is designed for, one, the general population, so we're trying to make it cheaper than what is available in the market, and two, we want to make it portable and dynamic so that people in the city and urban environments can use it. Our tasks, originally we had to get the electric motor, we spec'd one out and then purchased it, and then we had to test it. Me and Tyler were doing the frame design while Seth was configuring the controller. Then we actually got parts for the frame, fabricated the frame, did a final assembly including testing, and we were able to obtain the battery to power it and run our final tests and balancing. For our electric motor, we ended up using the Golden Motor Magpie after testing it against a number of other motors at the time. Our first test to power the motor was at the Hewlett-Packard. It was a power supply lab. We didn't have enough to actually power the motor. The second one was at the power lab downstairs in the main building. Our first attempt, we were able to power the motor, but only for a couple of seconds before it tripped the breakers. We were not able to obtain any results. Our third attempt was to try and use a rectified AC signal, but that did not power the motor. We found out later on the plugs we were using might have been malfunctioning, so that might have been why that didn't work. Finally, when we got the battery, we were able to fully power the bike and do all of our testing to get a final product. For the frame, we designed it primarily in Pro Engineer, as you can see with the picture displayed right there. We designed a full-size bike using 700C wheels. We wanted to put a book hinge in the middle so it's collapsible for our urban living and storage. And we wanted the battery placed in between the two frames, as you see, a little closer to the front for balancing concerns, so it's not as back-heavy as the previous bike we looked at. So it's a lot easier for the rider to ride, and it's not a hazard going around tight turns.
So before we designed the controller, we had a few considerations. The first thing we wanted to do, we know when we purchased the motor, it actually came with a throttle control. We knew right off the bat we wanted to get rid of that, add in discrete functions. So we have user inputs that will talk to the controller that we added for the user. Through those inputs, it'll output a voltage on the line that the throttle was on, which goes to the internal motor controller. And through these inputs, the internal motor controller determines how much power should be delivered to the motor. And we also wanted to add kill switches, obviously, for safety, because rider safety is obviously very, very important, and through the brakes and through actually a switch that the user can press. And this simpler controller is a lot cheaper than what is on the current Trek Ride model that was previously purchased. So here you can see, I discussed this earlier, we had a throttle control. The power was going in, and then output was going into the controller inside the motor. In our new design, basically we're replacing that throttle output, which is going here with our controller output, and the output is determined through software through 4 different inputs. Okay, so the software itself actually has 21 different assist states for the user. These states are controlled through switch capacitor DACs. It's a filtered signal. There's a wide range of assist levels because a user should be able to acquire an assist level for whatever environment they're in. Flat ground, downhill, uphill. Uphill being the main concern, but you have to consider all riding environments. And the more states actually correlates to a smooth power delivery. With just a few states, which we initially had, the power delivery was very jerky, dangerous for the rider. We added more states, the delivery is very smooth, you can't feel it jerk when you switch states, it's very nice. We also have 2 methods of killing the motor, as I mentioned earlier, one through the kill button and one actually through the brakes. The brakes act as similar to a clutch in a car. So if you pull in the clutch in a car, you're in 3rd gear. If you don't change gears when you release, you're going to be in 3rd gear again. With this, when you hit the brakes, if you're in state 10, when you release it, you're going to be in state 10 again. The kill button, on the other hand, completely takes it to state 0. No power will be delivered to the motor until the rider sees fit to actually increment the assist again.
So once we had modeled and designed our frame, we had to order the tubing and the other components for the frame. We did that from a company called Nova Cycle Supply, who specializes in bicycle frame components. And then when we received that, we went right to the Drexel machine shop and started mitering all of the tubing. This was a partial success. We were able to miter some of the bigger tubes, and then when we actually tried to miter the seat stays here, they're very thin-walled. to be lightweight, and they're also small diameter. And the machine shop at Hess is more set up for heavier duty equipment and machining. So the end mill we were using grabbed onto the end of, it bit the end of the seat tube and bent it. Luckily I was going to make another bike frame a while back, and I had an extra seat stay at home that we were able to machine. So we took all of the tubing back to my house where I have a drill press, and we got hole saws that were the right diameter, and finished all the mitering at my house, which was a complete success. And then the final step was the assembly of the bike. We had to put all the parts on it so that you could ride it. This was an iterated step of putting it together, taking it apart, making sure everything worked, and adding another part. Doing that several times until everything works. And then we were able to take it with on an unpowered test ride. And originally it didn't have this extra tube in it. And in all of our designs you can see it didn't have this extra tube in it. The reason that's there now is on the first test ride, while I was completely confident with the strength of the frame, it didn't flex any in this direction, which was actually our biggest concern. When you would pedal, the bottom bracket would sway to the side, which is somewhat normal on any bike frame. They have a little bit of lateral bottom bracket flex. But this was unacceptable in my opinion. There was way too much flex. So we added, well, luckily the bottom bracket was meant to have an extra tube in it anyway. We added this extra tube in, and now it's actually stiffer than the bike that I ride every day. So then we were able to go on a powered test we were able to test the motor in the lab on a power it up, and then we actually went out and took it on the road for a So then, this is some of the metrics from the test ride that I took yesterday. We had a full charge and we went out. We tested it around the clog once or twice, and then I actually started, I used an online program called Map Ride Ride, which you can route out your different rides. I went on a 26.5-mile bike ride. I took it around the city once, in this area, went out the bike path to Manayunk, up one of the steepest hills in Manayunk, then back down, back into the city and around the city some more. And the ride was unfortunate. It had just started reading half on our battery life only has 3 states, dead, half, and full. It was just starting to read half when I was coming away from a stop in the highest state, and I let go of the brake, and it actually torqued the motor out of the dropouts. And I didn't have the tools to fix it properly last night and continue the test. So I thought that we achieved our goal of 20 plus miles on a full charge in what seems to be a half a charge, so long as our battery gauge is reading the right one. And as I said, the biggest hill I climbed was actually a Category 5 climb. That's a bicycle rating. And this one in particular was half a mile at a close to 3% average grade.
And for our scheduling here, biggest one to pay attention to is the bottom graph here, where the red line is our predicted time frame and the black line is our what actually happened. As you can see, in most categories, unfortunately, we're behind our predicted schedule. However, we still did accomplish every task that we set out to do, with exception of mounting the actual hinge, but that was an administrative decision that was later made to not do it.
While we're getting that set up, here's the hinge, a prototype of the hinge that we would like to put in the frame.
Where's it going to go?
Right behind the battery box.
2 of them.
Yeah, 2 of them.
And this right here is a test ride around the
So here he's just riding it, not pedaling, just to show that it will assist. And on further tests, then we start pedaling.
Yeah.
Very good. Let's start with
Oh, it's only 20 more seconds.
oh, go ahead.
All right. Let's see what kind of strange looks you guys get right into the quad. Is it fun?
Absolutely.
So much fun. 26 miles yesterday. I was super upset when it was cut short.
Yeah.
I was having a blast.
Yeah. That's
That's
great.
just him riding into the sunset.
Dr. Navet, let's start with the committee question.
Very good, congratulations. Quite impressive work. To some extent, I could follow what you were saying that was related to that, as in how the assist engages, at what level it should engage so that it doesn't jerk the rider, or at the right level. And your final proposal for the controller, the tasks of the controller. Number one, so with it's not like the cruise control that you brake, it disengages. You have to do the kill button.
Yes,
Right.
as of right now.
The assist is working and you are braking as well.
No. As soon as you hit the brake, it cuts all. The brakes override any signals going to the motor.
Right. The brakes
Safety.
override any
Yes.
signals. And then the other question is that when you re-engage, where would it?
Picks
At
up where
what
you
state?
left off.
Yeah.
This is
At
the current
right
state
now.
you left off when you pulled the brakes in. You can change the states while you have the brakes in. So whatever state you're currently in when you release the brakes is where it'll pick up from.
And the manual brake then overrides the kill button. So you could
No, you can kill it with the brakes pulled in. You can do anything, move states, you can go through any states with the brakes pulled in. If you hit the kill button, it'll kill it. When you release the brakes, you'll have no power. You can move down, you can move up, but until you release the brakes, you won't see any of your changes. But once you release the brakes, if you killed it, you'll have no power. If you moved up, you'll have more. If you moved down, then you'll have less.
We forgot to mention before we ask your questions, tomorrow morning we'll actually have this available for any of you to ride. We invite all of you to come out. What time is it? We said we're going to have this one?
10 to noon or 10 to 2.
10 to 2.
Any chance I can talk you guys into the EC Expo / celebration tomorrow at 4 o'clock in the atrium? I will bribe you with beer and pizza if you come and...
But not for the rider.
Yeah.
Absolutely.
Gladly.
Doctor, I'd like to see Dr. Navet on this thing tomorrow. Dr. Mew.
The beer.
So overall, I think this is like very good. I just have some questions with respect to process, and since this slide is up, I'll reverse my order here. But so there are 21 assist levels. I can't count them out. That's almost like a state transition, like diagram what you have out there.
Right, this is
And
obviously very simplified. I didn't want to put 21 cluster you.
All
But
right. Well, so then this is fine, but whoever might come next, like the language doesn't match the diagram.
Right.
And then as a doubly, we're okay with 21 state. Do you we don't fear that number, although I realize for presentation purposes, you start looking at spaghetti. But you know what I'm saying, it just doesn't match.
A big thing to take away from this diagram is that it's symmetric in the case that kill button obviously moves you to off, up moves you to the next state, and down moves you to the previous one. So that will obviously be the same for all 21 states. Like you said, it would be spaghetti looking at that.
Yeah, I
Because
just
full
put that
documentation is important someplace.
This is what this is what my point is.
Right.
Full documentation, as you said, maybe there's going to be a team next year that wants to start, give them the manual on how to get this thing.
Right.
I'd like to add my congratulations as well. I loved it. I think you guys put in great effort, both mechanical and electrical. I mean, you guys really worked together as a nice team. These interdisciplinary projects are what I think the university should be the most proud of. This is going from department to department and coming up with a great project. So I'd like to again invite you tomorrow to our celebration, and maybe we can have a couple of people riding around.
You're on.
Perfect. Thanks, guys. Well done. You gonna paint it? It's gotta be cool,
Yes,
man.
yes, we're gonna paint it. We wanted to leave it raw so you could see all the welds and stuff.
That's impressive work. Better.
Thank you.
Go on. What's that? Go on.
Very well. Excuse me, guys.
What is it?
Dan, I really have to ride that bike.
I do.
That's awesome.
I was going down the hill.
You can't do it now, just leave it to it.
Thank you. It'd be easy for you to do the zero. Thank you.
Not necessarily.